All right, apologies. The hosting computer went down and cut our other one off. Sometime is gone. This is battery and battery. So hopefully this will last to the end. If not, so we'll have Brett pick up from where he'll pick up, and I apologize for the misconduct.
All right, just to rush through this, basically a poor version of us trying to inherit mountain bike from bicycle. It just so turns out that bicycle is not an abstract class at this moment because bicycle still contains the information from road bike, which is no good. We really want to find the abstraction. You shouldn't ever really expect to call new on the abstract superclass. And certain languages do provide syntax for creating abstract classes like Java. In Ruby, we don't. Even though we have two bikes, it's maybe not the best moment to create the inheritance, so you have to do a cost-benefit analysis, and basically one of the main determiners is how soon you'll need that third class. And this big point, which we'll go into multiple times, which is basically because creating an abstraction can be so difficult and you can leave so much left over, it's best to push all the code down into one of the subclasses or one of the peer classes and then promote it back up. And we'll go back into that a little bit more. So when we create this first shot at the inheritance with mountain bike and road bike, we move all the common functionality over to road bike, and mountain bike, which relies on some of that stuff, will be broken. So we slowly start to promote some of the functionality and the methods and all that to the abstract superclass. And just to go over it, that's very important. It's much easier to promote than it is to demote. So we're going to start by promoting the size behavior to the superclass, which has these three changes. The attribute, reader, and initialization code, we move from road bike to bicycle, we promote it up, and we add a call to super. This variable is set in bicycle's initialize method and a method that road bike also implements or overrides. When road bike overrides the initialize in the parent abstract class, it provides a receiver, and because of that, it never actually will call super. So it prevents the message's auto delegation up to bicycle. So now road bike is obligated to do the delegation itself. So we have to call super. It says this, I just put in, the alert reader will notice that the code that handles bicycle size has been moved twice. So first we moved it down to road bike, and then we moved it back up to bicycle. And that's really the point that Sandy kept on drilling in, which is the important thing, which is you might be tempted to skip that, but don't, because this push everything down and then pull some things up strategy is actually the easiest way to prevent failures. And if you begin this refactoring with the first version of bicycle, attempting to isolate your concrete code and push it down to road bike, any failures on your part will leave dangerous remnants of concreteness in the superclass. And what will happen if I'm wrong? So you might accidentally leave remnants. By definition, this leftover concrete behavior does not apply to every possible new subclass. And that breaks one of the basic rules of inheritance, which is it wouldn't truly be a specialization if you failed to demote everything. And because the hierarchy becomes untrustworthy, it forces objects that own to start to know their quirks. And then that just trickles throughout the application, and it creates more dependencies. So here's another example. Road bike and mountain bike both implement version of spares. this method sends super, expecting the superclass to also implement spares. And it's also expecting the superclass to return a hash. So we're going to start over here and say bicycles have a chain and a tire size. All bicycles share the same default for chain. Subclasses provide their own default for tire size, and concrete instances of the subclasses are permitted to ignore the defaults and supply instance-specific values. So this is our promoted version of the bicycle abstract class at the start. And we'll see that default chain is only implemented in the superclass, and we overwrite default tire size in the subclasses. Basically goes over to the last slide. You'll see, by the way, that in chain and tire size in these lines in the top, they fall back to these defaults that are supplied. So this is called the template method pattern, where the subclasses implement these methods that are used in the superclass. Okay, so imagine that FastV adds another new bicycle type, the recumbent. Bicycle's initialize method sends the default tire size, but bicycle itself does not implement it. So on the right, we create this new subclass recumbent, and we don't implement the default tire size. So when we start to create one, we see that it doesn't exist. And what's important here is that the original designer of the hierarchy would probably not encounter this problem because you'd know that you need that. But in a year or two, you have another developer, they just want to make a new specialization. They shouldn't have to know all these things. So there's a problem in the way that the template method is used here. But basically, it imposes a requirement on its subclasses, and they must implement default tire size. So we're starting to get in a situation where just to create a subclass, you have to actually know a lot about the superclass, which is not good, to say it shortly. It's not as bad as outside code, in my opinion, having to know about the class, but it's bad. Okay. Any class that uses the template method pattern must supply an implementation for every message it sends, even if the only reasonable implementation is sending a class that looks like this. So basically, this is saying, hey, if we know that a new developer is going to come in 2 years and they're going to make this new specialization subclass recumbent bicycle, the parent class should always, for every single method that's used with the template method pattern, define like a fallback, even if it's so poor of a definition or whatever that all it does is say, hey, you can't do this. And this is showing two different versions. Right off the bat, you could say non-implemented error, or you could give a little bit more detail. And it would make it a lot easier for the developer 2 years out to determine what the problem is. Okay, so now we're in the situation where we have all our code, and if I remember correctly, this is actually pretty much working fully. So it's not that bad. I think if I was reviewing this code, I probably wouldn't even have thought about this stuff that much. It works. If you're the original creator of bicycle and road bike and mountain bike, you call super, you expect spares on bicycle to return a hash, all good and dandy. But Sandy takes the next couple pages to describe why there's some problems with this. And you might notice it right off the bat, which is you have to have some knowledge of the parent class in order to even get the subclasses right when you're calling super args and the initialize methods, and you're expecting it to return a hash. So there's some ways around this. So basically, yeah, any programmer can forget to send super. And when you force the subclasses to know how to interact with its abstract superclass, it causes many problems. And on the left, we have an example of that. Basically, in the recumbent bike new subclass that the developer is creating 2 years from now, they might forget to call super, and look at that, tire size, chain, they're not set. Even though the parent class is supposed to take care of it all, it's easy to miss. So the solution to this in this scenario is actually to instead use hook messages. And we have the post initialization method, which we call from the superclass, and we actually get rid of implementing the initialize method entirely in road bike. So you can't forget to call super in the subclass if you never even have to initialize that subclass in that way anyway, or define it. So hook messages are basically ones that exist solely to provide subclasses a place to contribute information by implementing matching methods. Just 1 second. Okay, I basically said all this stuff, which is you don't even have to have the initialize method. It's all handled through the hook method process. This change allows road bike to know less about bicycle, reducing the coupling between them and making each more flexible in the face of uncertain future. Okay, so this same technique can be used to remove the send from the super or the spares method. Instead of forcing road bike to know that bicycle implements spares and that bicycle's implementation returns a hash, you can loosen coupling by implementing a hook that gives control back to bicycle. And that's the local spares method on the right. Here's, let me see. Yeah, okay. So here's the final code at the end, actually. And I guess the thing that comes to my mind is, look how beautiful it is. It's pretty easy to understand. And if you had to add a new class, it would be pretty straightforward. It's pretty hard to forget calling super when you have this post initialization thing, and you don't even have to call super. I don't know if I could call it fail-proof, but it's some beautiful code, I guess. I'll let you just look at that for a little while. But that is the final solution, and we see that example with adding a new subclass, the recumbent bike. It's pretty easy. I think she used the example. It's kind of like factory worker process. You could just churn them out and not even have to think that much. And I guess a lot of it is you would look at the parent class. You'd see these post initialized. Sorry, I need some water. Methods, and it will be a little bit more clear, and it's more difficult to scroll. And the summary of this is, inheritance solves the problem of related types that share a great deal of common behavior but differ across some dimension. It allows you to isolate shared code and implement common algorithms in an abstract class, while also providing a structure that permits subclasses to contribute specializations. The best way to create an abstract superclass is by pushing code up from the concrete subclasses. Identifying the correct abstraction is easiest if you have access to at least 3 existing concrete classes. Abstract superclasses use the template method pattern to invite inheritors to supply specializations, and hook methods are used to allow inheritors to contribute these specializations without being forced to send super. That's actually it. I'll go back to this as our beautiful code example. Does anyone have any questions or any statements? Or?
You hear me?
I can hear you.
I have some comments on that. First thing, I seem to recall, and whose feedback? Am I getting feedback from Brett? I think I am. Is it not the standard practice to always call super and initialize, and but not necessarily in the other methods that you redefine? I seem to recall being told somewhere you should, if you're going to reuse behavior, which is the whole purpose of subclassing, then of course you want to reuse the constructor. To always call super in your initialize. Now, whether you call super and then run your stuff, or run your stuff and then super because it prepares something that goes into super, it's sort of up to you. So I kind of think that's the default. Finding methods that are not that one, you may intentionally not want to call super. That depends on what your subclass is doing. So number one, I'm thinking, oh, we forgot to call initialize. But one thing, I think a class that inherits, that doesn't call super on initialize, is doing something radically different from the parent. And you're kind of just forcing it into the hierarchy for no, I don't know, just cause. So it's like it's not a real subclass because it didn't need the parent's initialization. So number one, I'd say that's different. The other part about not having to know too much about the parent, I go, you have to know enough to make the hooks work. So I disagree that you don't know something. You have to know what the hooks are. And if you're doing template method in general, this is one place where statically typed is better because your parent class or interface message you need to have in template method and force you to implement those. So that's a place where the compiler can tell you you're not implementing required methods. It's one of those places where Ruby is actually, you got to do a little more work there. But once you have a implement the template, if it's not in the parent class. So I think it's elegant. I think the post hooks are cute, but I don't think in both cases it really addresses the fact that just use what is. And again, static typed languages would make that easier for you, which is, actually less good in dynamic languages here. And then the original one is if you're doing a subclass and you're not calling super, I suspect that's a smell that you're doing something radically different because you're inheriting something and then not using the parent's initialization code, which is the source of the data for whatever behavior you're inheriting. No, she's saying, oh my God, you should not, you could forget to do this. You could forget to be post initialized. How does that help you? The point in super and initialize, I say something is wrong from the get-go. So I would say the prereq to that is you should always call super and initialize whenever you inherit something and you need to specialize stuff. But it helps somewhat, but it's like it doesn't take the fact that if you're initializing and you don't call super on your class, because it's not. If you're fitting stuff in initialize and you don't call super first, then you are doing something quite different from the parent, which makes me wonder if you even should be a child class of parent. Not always the case, but I would say 99% likely. I would not be surprised if every Java course taught in every college says, always call super in the constructor.
So that focusing not on the initialize super thing, but focusing on local spares, I think that's an easier one to discuss in the sense that local spares, what if you change the parent to not return a hash? I do see what you're saying with regard to, okay, if you're going to call post initialize or local spares, yeah, you have to know something about the parent. So that rings a bell with me. It's kind of like, well, you have to understand the code a little bit, but I guess there's a smaller chance you'll screw up, and it shows clearly that the subclasses add information. But let's talk about local spares in the sense that, yeah, if we all agree that you're always supposed to call super in the initialize method, the local spares one's better. Do you have more to say about that one?
Yeah, that's I like. I mean, it's fairly elegant to have that. And local spares is the kind of code I would make when I'm trying to figure out how to basically how to make the template. So you'll come, and the way it happens is you have like 2 classes, and you add the third, and you're going, oh crap, how do I fit this in? Oh, you make a new method. It goes back to that line where they say one level of indirection can solve almost all problems, or another level. And so local spares becomes, oh, well, if each one has to add this here, we can do this one. I think that's okay. I think that's a little cleaner than, I forgot what the original, the pre-local spares solution was, but it was pretty much, did she like pull that out of the initializer or something like that?
It was spares and you did super dot merge. You had to expect it to be a hash.
Right. Okay. It's a cleaner. It's a little cleaner, but in both cases, it's a hash. You know the parent's a hash. You're merging a hash, and local spares, you're still an array in there. It's broken.
So let's say you change the.
Go ahead.
Let's say you change the parent spares, then. I guess it's easier to recognize, okay, now I have to go change it in all the subclasses. Whereas, yeah.
I'd like the end design. I'm just saying, what am I saying? I don't know. I don't that one as much as the initialize. I'm just saying, you do have to know. If suddenly the parent starts using, I don't know, something that's not a hash, you could backwards proof it by still making it use local spares in the correct way. So that would allow the parent to change representation and not change the children. That's good. It does give you that. Though in this particular case, super is a hash and this is a hash. It's possible. It could save you something. It doesn't necessarily save you something. The thing it goes back to the fact is this idea, you shouldn't know anything about the class. Well, you have to. And if you're using template method, which is a pattern I use all the time, I guess it's one of my favorite patterns because it's very useful. You have to know what's in the template. I don't see a way around not knowing, sort of being a static type language, which tells you up front, here, you must implement these or else you got a problem.
Yeah, no, I thought that was interesting. It's like you do have to, how do you even know to call local spares? Or
right, you wouldn't know. And if you looked at, let's say you look at another subclass, he doesn't redefine local spare because his name would change. I don't know that because it's not in that code. I have to go up to parent class. Right? You know how you cut and paste. Well, here's another subclass. I'll just cut and paste. Well, he didn't define local spare because he didn't have a difference. So you have to go to the parent to see. So I don't see how it saves you looking at the parent class.
So one thing that I can think that comes to my head, but I would love if someone else has like any thoughts about it to interject, is with the previous implementation. Okay, so in this implementation, actually, if you decide that you're going to change spares to not be a hash or just do something different, you see local spares, so you go, oh no, I know I need to fix local spares.
Yeah, well, like I said, you could change it in the parent and then have that method deal with a hash and not change the children.
Right. I guess what I want to say was if you change spares here, it's not as clear that there are other places that it's overwritten. Like you might go in here and change it.
That's always an option for any OO class. If you got a class in the parent, it can always be overwritten.
Yeah.
So you have to check. And ultimately, because we're not statically typed, you should have tests to check that stuff. You make a change like that in Java, and suddenly the children don't compile.
So I will just say randomly that one of the two biggest takeaways I got from this is it's easier to promote than demote, and also the fact that you should wait for 3 examples if you can.
Yeah. That seems to be the most number. I thought it was good. I just had a little like always super and You always have to know something about the parent when you subclass. And that was my counterpoints. Yeah, the actual code is pretty elegant. I like the hooks.
One thing I will notice, I don't want to use any like hedge specific examples, I guess, but there's a lot of times where I'll create a subclass after I'm already using that parent class. So I'm, you know, for a year, that parent class, the original class is being used. I'm probably breaking the rules in the sense that the subclass maybe isn't fully specialized. I guess what I'm trying to say is there's scenarios where I've used a class for a long time and then created a subclass, and that original class, the parent class, is not truly an abstract class. So is there anything you could say about that, in the sense that in the book she tries saying, hey, abstract classes, you should never call new on them, but you know, I guess what I'm trying to say is there's a difference between having parent classes and parent abstract classes.
You know, I don't think you have to have an abstract class. It gives you, the perk, I believe it gives you is that if you're in a static language, you never have to change anything because you have an abstract class. So in Java, they always tell you, you know, I forget the language, but always make your interfaces deal with abstract classes. This allows you to have any subclass and you never have to recompile. Now, because in Ruby, we duck type, doesn't matter. So you don't have to do that one, right? You could have, because in your class that uses children, it just calls methods. It doesn't really care about the hierarchy. So it's something that will trip you up in a static language. Let's say I put a concrete class, and now I have two subclasses.
Right.
I may have to change the parent to abstract so I can, the hierarchy can cause things to not compile. That never happens in Ruby. And so part of me says, well, you know, if I could skip one less abstraction in my brain, I would like to. So I'm kind of, you're not putting an abstract parent and then putting a subclass. And if you only have one subclass, it's like, I think it's okay for abstract parent to have implementation. And template pattern at least counts on your parent having a structure. And it fits you in inheritance to move common functionality higher. I don't have a problem with abstract methods having functionality, and I think most will. Now, should it be something you never instantiate? I don't know. We'll go with the bike thing. We have bike, we have mountain bike, we have recumbent bike, we have, I forgot the other bike. I'm okay with top level bike, plain bike, or no frills bike. I can go to Target and buy a no frills bike for $50. I don't know. It might be kiddie bike. Is that even? Right. So I don't have a problem with the parent being unadorned, whatever class. And because we use Ruby and we don't get caught flat-footed by not having some abstract thing, a lot of times all that stuff matters more when you have single inheritance interfaces and static typing. So it's Ruby, so I don't care as much. It's a little more elegant at the problem of another class, which may or may not be a big deal. It's 3 additional classes, so I don't know.
Comment, serialized comment. So one example I always think when I think of inheritance, I like this example. I always use shape, rectangle, square, circle, triangle. Whenever I describe it to someone.
Yeah, that's a good one.
Because, you know, the rectangle, square thing, and then shape. I guess shape could be abstract. Anyone have any thoughts?
Conceptually, that's true. Hey, someone else talk besides me. Jeez. Sam.
Now we're calling people out individually.
Yes, we've gone to.
Alex is still eating tacos.
Diego has. I can't believe Diego has.
All right, I think that's it. If no one has anything to say.
Diego has been out since the outage, so I don't know where he went off. I think he's taking care of business.
Taking care of business. Okay, well then we're wrapped up. This is almost time to wrap up. I will see if I can stitch the two together, but I suspect without a lot of work, I just have to post two things up. Who shall do it next time? Who hasn't done it next time?
I think everyone's done it, except maybe Diego. Did Diego do it? Hey, Diego's not here. I'm gonna volunteer.
Diego was number one, and if you recall, he thought we could do 3 chapters and. Scott, has Scott gone?
I'm not done.
Scott has not gone. I think. All right, Scott's taking it. Scott's doing chapter 7. We'll do chapter 7 in 2 weeks. Thank you. Welcome to Nested Loops. If anyone who's not part of us sees this, you're welcome to join and participate. You're welcome. I suppose I should go and put it on the site and advertise a little bit. So yes, tell your friends. Come discuss. Then you can hear less of me.
How to get reliable power.
Yes. All right. Thank you.
Take it easy.